This next test is called the nth root test, and it's very similar to the ratio test. So if we have a series, and again it might be a series with positive or negative terms, and if we calculate this limit, the limit as n goes to infinity of the nth root of the absolute value of n, and again suppose we end up with something which is less than 1, then we can conclude absolute convergence. And if we end up with something which is bigger than 1, we can conclude divergence. And if the limit equals 1, as with the ratio test, this test is inconclusive. So let's check it out on this series. What does it say? Well, we calculate this limit. So first of all, I need the formula for an, and that is minus 1 to the n minus 1 times 2n over n plus 1 to the n. Now, having an nth power here is a good indicator that the root test might actually be effective here in deciding whether this is convergent or divergent. So what I need to calculate is the limit as n goes to infinity of the nth root of the absolute value of an. And now filling in the details, I get that that is the limit as n goes to infinity of the nth root of the absolute value of what I've got here. Minus 1 to the n minus 1 times 2n over n plus 1 to the n. Now the absolute value means I can throw away this minus 1 to the n minus 1 because it's either plus or minus 1, so it makes no difference to the absolute value. So this is equal to the limit as n goes to infinity of the nth root. Now, when I throw away this minus 1 to the n minus 1, remember n is bigger than or equal to 1, so this is always a positive number. And so therefore its nth root is a positive number, so I can just throw away these absolute value signs. So this is 2n over n plus 1 to the n. Now we're taking the nth root of an nth power, and so that's equal to the limit as n goes to infinity of just 2n over n plus 1. Because the nth root of x to the n is just x. Okay, for x bigger than 0. So this is equal to the limit as n goes to infinity of this rational function. So I divide by the highest power of n in the denominator, so that's the limit as n goes to infinity of, that's n, 2n over n plus 1 over n, and that is now equal to the limit as n goes to infinity of 2 over 1 plus 1 over n. So this goes to 2. Now what does the test say? It says if I calculate this L and it's bigger than 1, then the series diverges. So this implies that the series diverges.